So let us discuss. So this is related to something secondary electrode. So let us say you have calomel electrode, that is Sg2Cl2, and this gives you Sg plus 2Sg plus 2Cl minus. And now this is a standard reduction potential 2E. The question says the standard reduction potential for calomel electrode is 0.28. So this is E degree for this L is given. So this is 0.28. Are you getting? And now also given two different arrangement 1.18. So if I combine calomel electrode with zinc electrode, so let us say zinc has to be oxidized, so Zn2 plus 2 electron, and now in this case let us say call this E degree as Zn2 plus, and this value let us say x. Now if you add these two, I will have this 2 electron goes, so we can calculate E degree, that is Sg2Cl2 plus Zn, and this side will have 2Sg, Sg is a liquid, and now Zn2 plus 2Cl minus, and now E degree will be E degree cell, basically this is equals to x plus 0.28. X might be negative, that can be found only from the data, and this says if I add with zinc, the reduction potential E degree is 1.083. so this is 1.083, and this is equals to x plus x, so this is x plus 0.28. so from here I can calculate x. So what is the x? So now I have x, so let us calculate 1.083 minus 0.28, so this value is 0.803, so x is 0.803, so 0.803, so this is the volt. Now let us say second combination. You have Ag2Cl2 calomel electrode with copper electrode. So first reaction is same. So you have first reaction is same, Ag2Cl2, and this gives you Sg and plus Cl minus. And now E degree for this reaction is given 0.28. E degree for this reaction is 0.28. Now this is your again reduction potential, and you have copper, so you will have copper 2 plus 2 electron, and let us say E degree copper to copper 2 plus, and this value is Y. So we can add these two half cell, and I can get the full reaction as Sg2Cl2 plus copper, and this will give you 2Sg plus Cu2 plus Cl minus plus 2Cl minus, and this is equals to basically E cell, E degree cell, so this is equals to E degree cell, and this value comes out to be Y plus 0.28, but E degree cell is given, that is 0.018. E degree is given 0.018, so this is 0.018. This is equals to Y plus 0.28. So from here I can calculate Y, that is 0.018 minus 0.28. Are you getting? So let us calculate. So this value is 0.018 minus 0.28. So this is negative. 0.28. So let me check. This is again, let me write 0.018 minus 0.28. This value is, I think somewhere some mistake. Let us do again. 0.02018 minus 0.028 or 0.28. This value is minus 0.262. So this value coming out to be minus 0.262. Now see, in this case E degree copper to copper 2 plus is Y, but that is coming negative, so basically this side reaction is more feasible. One more important point you see in this reaction, what we have done, E degree in both cases positive, E degree cell is positive, That's why in both reaction I have assumed Hg2Cl2 is reduction and the rest of the half goes to oxidation. Then this case zinc is oxidation, and in another case you have this is reduction, that's okay, but now this is oxidation. So the nature of electrode we have not changed, so the reduction happens of calomel electrode, but copper and zinc goes oxidation because E cell in both cases remains positive. Now let us say construct a Danial cell. So what is the Danial cell? This is negative, so I can generate a Danial cell, either Zn2 plus 2 electron, and E degree for this cell is Zn2 plus 2 x we have calculated, that is 0.803. so E degree for this cell is 0.803. so zinc will reduce, and copper you see copper oxidation. If oxidation of so zinc is oxidation, if oxidation of copper happens, this is a negative degree. So what we can do is, let us take reduction of copper. So copper 2 plus 2E, and I have to cancel the electron, and that's why I have to take one oxidation, another is reduction, and E degree in this case this will be plus 0.262 because I have to make a minus sign. And now if I add these two reactions, so 2 electron goes, so I will have Zn plus Cu2 plus, and this will give you Zn2 plus Cu, and now E degree is simply this plus this. So E degree cell is nothing but 0.803 plus 0.262. So let us calculate this value, 0.803, so 0.083 plus 0.262. So this is 0.3, so I think somewhere I have done mistake. This is 0.083 is not 0.803, because I know this is a 1.1 volt. So Danial battery has a voltage of 1.1. So this answer should be come out to be, yeah, this is 1.09. So E degree cell is 1.09. So you can remember this value for Danial cell. This voltage is around, so approximately E degree cell is approximate value is 1.1 volt. So this is the voltage of a Danial cell. You can check the answer of this question again. So this is 1.1 volt. Important point, in both cell you have not to change the nature of the electrode. In one case is reduction, then you have to another case also calomel electrode has to be reduction. If E cell has changed its sign, then you can change. If this E cell, if this sign is positive, this is negative, in that case you have to change the nature of electrode. But if this sign and this sign is positive, you cannot change. Let us discuss next.